Special graph.
Special graphs. X is equal to a number is always a vertical line. I'll show you some example here. X is equal to a number is always a vertical line. For example, the equation for this line is x is equal to 2. The equation for this line, tell me. Very good. X is equal to negative 3. If I drew a line right here, it would be x is equal to what? A half, wouldn't it? Okay? That's the first special case. You see these things on tests all the time. Okay, what am I going to write next? Y is equal to a number, right, is always a horizontal line. And let's do a couple of those here, y, x, right? Like this. The equation for this line is y is equal to what? 3. The equation for this line, for example, is y is equal to negative 1. So those are the two special cases. So give you a minute to get those down. Moving right along. Actually, I'm on the second page already. Boy, I'm really moving here. All right. Oh, look at this. Look at problem 10. Boy, are we good. Problem 10, we have to simplify this. The square root of 108 minus the square root of 75 plus the square root of 48. Do you notice that those numbers are on my special list? Isn't that nice? This problem could take some people 3 or 4 minutes to do, but it's probably going to take you about 20 seconds or less. 108 is a special number. It happens to be 36 times 3. 75 happens to be 25 times 3. And 48 happens to be, you tell me, 16 times 3. Look at all the time this is saving us. That you know these special numbers. Every teacher has these on tests all the time. All right? So from 36, I can take out a 6, can I? And for 25, I can take out a 5. And for 16, I can take out a 4. These are called radical-like terms. They're called radical-like terms. The 6 is called a coefficient. The negative 5 is called a coefficient. And the 4 is called a coefficient. This is no different than saying 6x minus 5x plus 4x. It's no different than that. These are called radical-like terms. So all you do is you add and subtract the coefficients, and the square root of 3 stays the same. So let's see. 6 minus 5 is positive 1. 1 plus 4 is 5. There's your answer. Okay? All right, moving right along. Here's another simplified problem. This is why I didn't do number 5 before. I'm going to do 12 actually. I'm skipping 11. Let's do 12. X minus 2y plus 4y is 3. All right? You're trying so. Now, you should learn and you should know that when you have a minus sign in front of a parentheses, every sign of every term changes. It's the same as distributing negative 1, isn't it? A lot of you know that. So when there's a minus sign, all you do is you remove the parentheses and you get a minus x and you get a plus 2y, and then let's just write the rest of it like that. All right? Now let's see, aren't these like terms right here? and nothing else is. So 2 plus 4 is what? 6. So you get 6y, and there's your answer for that. Okay, there's your answer for that. Grab my paper here. Okay, number 13. Lucky number 13. We have to solve for y here. Is equal to what? 4. When you solve for a letter, you want to first isolate the whole term that has that letter in it. Don't do anything else before that. Get this term by itself. So what I'm going to do is subtract 9x from both sides. So I get negative 7y is equal to 4 minus what? 9x. Now what do I do? Divide by negative 7, right? Now I divide by my negative 7. And so the answer is 4 minus 9x over negative 7. Now there's another way to write that answer. Let's see if that answer is there. Is it? Actually it is. Isn't it B? Yeah. It's choice B. Okay, we're fine. We're fine. Okay, let's look at number 14.